Introduction. Hello students. In this episode, we are going to study various separation techniques. Separation techniques are used on mixtures which can be either heterogeneous or homogeneous. There are various separation techniques and the correct method is selected based on chemical properties or physical properties of the mixture such as size, shape, mass density, chemical affinity. The purpose of separation may be analytical, that is, analyze components in the mixture, or may be preparative, that is, to prepare fractions of a component that can be saved. So let us take a look at different types of separation and analytical techniques one by one. 1. Filtration. Filtration is the process that separates a solid from a liquid in a heterogeneous mixture by a use of filter. For example, separating a precipitate from the solution in which it was formed. The mixture is poured into a funnel containing a filter paper. The solid residue remains in the filter paper while the liquid filtrate passes through the filter paper to be collected separately. Because of the attractive forces between the solid particles, they form pieces of the solid material which are too large to pass through tiny pores in the filter paper. 2. Crystallization. Crystallization is a technique which uses evaporation to remove a solvent from a solution in order to leave the dissolved material behind as crystals by heat. 3. Chromatography. Chromatography is the most important technique for separation. It is defined as a method in which the components of a mixture are separated on an adsorbent in a flowing solvent. Chromatography is a collective term referring to a group of separation processes, and all different types of chromatography are based on the concept that the sample to be examined is allowed to interact with two physically distinct entities, a mobile phase and a stationary phase. The sample generally contains a mixture of several components to be separated, and the molecules targeted for analysis are called analytes. Mobile phase can be liquid or gas, and it moves the sample components through a region containing the solid or liquid stationary phase, which is called the sorbent. The components in the sample distributes themselves between the mobile phase and the sorbent and interacts with the stationary phase. If the analytes present in the sample has high affinity for the sorbent, their movement will be retarded through the chromatographic system. Molecules that show weak affinity for the sorbent are easily removed or eluted from the system. Let us now focus on various types of chromatography techniques used for separation. Classification of chromatographic methods. A. Separation based on attractive forces. The mechanism of separation depends mainly on the nature of the stationary phase. Based on separation mechanisms, chromatography can be categorized into adsorption chromatography. It is the oldest and most common type of chromatography method. It is a type of chromatography in which a mobile liquid or gaseous phase is adsorbed onto the surface of a stationary solid phase. The equilibration between the mobile and stationary phase accounts for the separation of different solutes. Separation occurs because of the fact that an equilibrium is established between molecules adsorbed on stationary phase and those which are flowing freely in mobile phase. The more the affinity of the molecule of a particular component, less will be its movement. Silica gel is the most common stationary phase in adsorption chromatography. Application. It is used for separation and identification of peptides and proteins, fats and fatty acids, antibiotics, narcotic analgesics, glycosides, amino acids, etc. Partition chromatography. This form of chromatography is based on a thin film formed on the surface of a solid supported by a liquid stationary phase. Solutes equilibrates between the mobile phase and the stationary liquid. Separation of components of a sample mixture occurs because of partition. Stationary phase is coated with a liquid which is immiscible in mobile phase. Partition of component of sample between sample and liquid or gas stationary phase retard some components of sample as compared to others, and this gives basis for separation. The stationary phase immobilizes the liquid surface layer, which becomes stationary phase. Mobile phase passes over the coated adsorbent, and depending upon relative solubility in the coated liquid, separation occurs. The component of sample mixture appear separated because of differences in their partition coefficient. Application. It is used for separation and identification of amino acids, carbohydrates, tannins, glycosides, alkaloids, etc. Ion exchange chromatography. It is used for separation of charged molecules. The stationary phase is an ion exchange resin to which a cationic or anionic groups are covalently bonded. Ions of opposite charges in the mobile phase will be attracted to the resin and compete with the components of the mixture for the charged group on the resin. Both the mixture components and the mobile phase must be changed. Mixture of alkaloids which contains positive charge can be separated on an ionic exchanger, while mixture of organic acids which bears negative charge can be separated using cationic exchanger. Application. It can be applied for the separation and purification of many charged or ionizable molecules such as proteins, peptides, enzymes, nucleotides, DNA, antibiotics, vitamins, etc. Molecular exclusion or size exclusion chromatography. This type is also known as gel permeation chromatography, molecular sieve chromatography, gel filtration chromatography, or gel chromatography. In this method, the liquid or gaseous phase passes through a porous gel which separates the molecules according to its size. The pores are normally small and exclude the large solute molecules, but allows smaller molecules to enter the gel, causing them to flow through a larger volume. This causes the larger molecules to pass through the column at a faster rate than the smaller molecules. The gels used in this method, which act as molecular sieve, are cross-linked polymers. They are uncharged and inert, that is, they don't bind or react with the material being analyzed. Application. It is used for purification of enzymes and other proteins. It is used for estimation of molecular weight of globular proteins. Affinity chromatography. This method is the most selective type of chromatography. It utilizes the specific interaction between one kind of solute molecule and a second molecule that is immobilized on a stationary phase. For example, the immobilized molecule may be an antibody or to some specific protein. When solute containing a mixture of proteins are passed by this molecule, only the specific protein is reacted to this antibody, binding it to the stationary phase. This protein is later extracted by changing the ionic strength or pH. The stationary phase is typically a gel matrix. The molecule of interest has a known and defined property. The process is an entrapment in which the target molecule becomes trapped on stationary phase. The stationary phase can then be removed from the mixture, washed, and then target molecule is released from the entrapment. Application. It is used to purify and concentrate enzyme solution. It is used for purification of recombinant proteins and antibodies. B. Separation based on mobile phase. B.1 Liquid Chromatography. In liquid chromatography, the mobile phase is liquid. In case of separation by adsorption, The stationary phase is solid, so it is called liquid-solid chromatography. For example, adsorption chromatography, ion exchange and size exclusion chromatography. If separation occurs through partition, the stationary phase is liquid, so it is called liquid-liquid chromatography. For example, partition chromatography. HPLC, high performance liquid chromatography. HPLC is a type of liquid chromatography where the sample is forced through a column that is packed with a stationary phase composed of irregularly or spherically shaped particles, a porous monolithic layer or a porous membrane by a liquid which is mobile phase at high pressure. HPLC is a powerful tool in analysis. It yields high performance and high speed compared to traditional column chromatography because of the forcibly pumped mobile phase. It is used in biochemistry and analytical chemistry to purify, identify, and quantify the individual components of mixture. HPLC separation technique involves the injection of a small volume of liquid sample into a tube packed with tiny particles where individual components of the sample are moved down the packed column with liquid mobile phase forced to the column by high pressure delivered by a pump. These components are separated from one another by the column packing that involves various chemical or physical interactions between their molecules and packing particles. These separated components are detected at the exit of column by a flow-through device or detector that measures their amount. The output from the detector is called a liquid chromatogram. In principle, LC and HPLC work the same way except the speed, efficiency, sensitivity and ease of operation of HPLC is vastly superior. B.2 Gas Chromatography. In gas chromatography, the mobile phase is inert gas nitrogen or helium. Here, if the stationary phase is solid, it is called gas-solid chromatography, and when the stationary phase is liquid, it is called gas-liquid chromatography. Separation based on the method of holding the stationary phase. C1. Planar or plane chromatography. In this type of chromatography, the stationary phase is used in the form of layer and it is classified as follows. A. Thin layer chromatography. Separation in TLC involves distribution of a mixture of two or more substances between a stationary phase and a mobile phase. The stationary phase is a thin layer of adsorbent, usually silica gel or alumina coated on a plate, and the mobile phase is a developing liquid which travels up the stationary phase, carrying the sample with it. Components in the samples will get separated on the stationary phase according to how much they adsorb on the stationary phase versus how much they dissolve in the mobile phase. B. Paper chromatography. It is a method of partition chromatography using filter paper strips as carrier or inert support. It is a chromatographic analytical separation technique for complex mixtures involving the progressive adsorption of the dissolved component onto a special grade of paper. With capillary action, the solvent will move up to filter paper. Movement of a solvent will bring together components that are separated from the mixture. Every component that are separated will move to several velocity. At the end of the process, components that are separated will emerge to different distances on filter paper. RF values are used for identification of each component. The retention factor or RF is defined as the distance traveled by the compound divided by the distance traveled by the solvent. C2. Columnar or column chromatography. Column chromatography is one of the most useful methods for the separation and purification of both solids and liquids. In column chromatography, the stationary phase is packed into a tube made of glass or metal, and the mobile phase is a moving liquid or gas. Examples of column chromatography includes affinity chromatography, ion exchange chromatography, molecular exclusion chromatography, etc. 4. Centrifugation or hydrodynamic method analytical separation. Centrifugation is an analytical separation technique based on the behavior of particles in an applied centrifugal field. Separation of particles in mixture takes place according to the difference in sedimentation rate or difference in buoyant density. A centrifuge is a device that separates from suspensions or even macromolecules from solutions according to their size, shape, and density by subjecting these dispersed systems to artificially induced gravitational fields. If a particle is in a centrifugal field generated by a spinning rotor with angular velocity omega, the centrifugal force is given by Fc is equal to m omega squared r, where m is the mass of the particle, r is the radial distance from the center of rotation, and omega is the angular velocity. Centrifugation techniques are classified in two categories. Preparative centrifugation, which is applied and for the separation or purification of biological samples such as cells, organelles, macromolecules, etc. by sedimentation, and analytical centrifugation, which is applied to measure physical characteristics of biological samples such as purity, size, shape, and density of macromolecules. Ultracentrifugation. A. Preparative ultracentrifugation. Preparative ultracentrifugation includes two methods, differential centrifugation and density gradient centrifugation. A.1 Differential Centrifugation. It is also termed pelleting and it fractionates particles according to their weight. The suspension of isolated organelles is spun for different combination of speed and time. The lowest speed and shortest time separates out the heaviest organelles, whereas the high speed and longer time separating the lightest organelles. A.2 Gradient Centrifugation. Gradient centrifugation includes rate zonal and isopycnic centrifugation, and the solute subjected should have following. The solute should be stable in solution. It should be totally inert towards biological materials. It should not be absorbed in the UV or visible. It should be easily and completely removable from the purified particles. It should be inexpensive and readily available. A. Rate zonal centrifugation. In this type of centrifugation, particles are separated in terms of their molecular mass. The sample solution is layered on top of the density gradient, and under centrifugal force, the particles will begin sedimenting through the gradient in distinct zones, each zone consisting of particles characterized by the same sedimentation rate. B. Isopycnic centrifugation. Isopycnic means of the same density, and this type of centrifugation takes advantage of differences in the effective buoyant densities of particles. It does not rely on particle sedimentation rates and molecular mass. Each particle sediments only to the position in the gradient at which its own effective buoyant density is equal to the actual gradient density. B. Analytical ultracentrifugation. Analytical ultracentrifugation is the study of the behavior of macromolecules in solution under the influence of a strong gravitational force. It is a centrifuge with one or more several optical detection systems which allow the observation of the fractionation process while the sample is centrifuged. Analytical ultracentrifugation technique uses either UV absorption optics or fluorescence detector for detection. 5. Electrophoresis, analytical separation. Electrophoresis is the process of moving charged biomolecules in solution by applying an electric field across the mixture. Biomolecules present in the mixture moves depending on their charge, shape, size, and separation occurs on the basis of molecular size. Electrophoresis is an analytical method used for separation and purification of large molecules such as proteins, nucleic acids, and for simpler charged molecules such as sugars, amino acids, peptides, nucleotides. When charged molecules are placed in an electric field, they migrate towards either anode, which is the positive, or cathode, which is the negative pole according to their charge. Electrophoresis can be one-dimensional, that is, one plane of separation, or two-dimensional. One-dimensional electrophoresis is used for most routine protein and nucleic acid separations. Two-dimensional separation of proteins is used for fingerprinting. Common media used here are polyacrylamide or agarose gels. PAGE, polyacrylamide gel electrophoresis. PAGE is a type of gel electrophoresis whereby the normal gel is replaced with polyacrylamide gels used as support media. In this method, gels are made by free radical induced polymerization of acrylamide and N,N methylene bisaccharyl amide. It is the most widely used technique of electrophoresis. In this method, ethidium bromide, silver or Kumasi blue dye may be used for visualization of molecules in the gel after the completion of electrophoresis. PAGE can be of two types. One, STS PAGE, which is a modified version of PAGE whereby sodium dodecyl sulfate SDS is used. STS is an amphipathic surfactant which denatures proteins by binding with its hydrocarbon tail. In STS PAGE, separation is based upon the molecular weight of proteins, and it is the most common method for determining the MW of proteins. It is also useful for checking purity of protein samples. Native PAGE, in which separation is based upon charge, size, and shape of macromolecules. It is useful for separation and purification of mixture of proteins. Isoelectric focusing. Isoelectric focusing is electrophoretic method that separates proteins according to their isoelectric points, PI. This method is ideal for separation of amphoteric substances, and the separation is achieved by applying a potential difference across a gel that contains a pH gradient. Isoelectric focusing requires solid supports such as agarose gel and polyacrylamide gel. This method gives good separation with a high resolution compared to any other method. Two-dimensional gel electrophoresis, 2DGE. The aim of two-dimensional electrophoresis is to separate and display proteins from a mixture. The first dimension of 2DE is isoelectric focusing, where the proteins will be separated based on their PI, and the second dimension is STS PAGE, where they will be separated based on their molecular weight. Colorimetry and spectrophotometry. Colorimetry and spectrophotometry are based on the absorption of light via matter. In colorimetry, polychromatic light, and in spectrophotometry, monochromatic light is used. If the compound to be tested is measured in visible light, then it must be colored. But if the compound is tested in ultraviolet and infrared spectrum regions, then the solution must be colorless. Also, depending on source of light, the instrumentation will differ. The spectrophotometer is an analytical machine that measures the transmission of a beam of light through a sample or the amount of light that does not pass through a liquid. Principle of Beer-Lambert law. Beer's law states that the absorbance is proportional to the concentration of the solution. Lambert's law states that for a given solution, the absorbance is proportional to the path length of the light through the cell. These two laws were combined and are known as the Beer-Lambert law. Beer-Lambert's law is the linear relationship between the absorbance and concentration of the absorbing sample, that is, a logarithmic relation exists between the transmission of light through a substance, T, and the product of absorption coefficient of a substance, alpha, and distance traveled by the light through the material, path length, L. Monochromatic light passing through a colored solution is partly absorbed, I0, and partly passes through. The intensity of arriving light, I, is decreased due to the absorption. Therefore, the transmittance T is equal to I by I0. Transmittance of a solution is in relation with absorbance according to the equation A is equal to log 1 by T is equal to log I0 by I. Instrumentation. Colorimeter is any tool that characterizes color samples to provide an objective measure of color characteristics. Colorimeter allows the absorbance of a solution at a particular frequency of visible light to be determined. It relies on the principle that the absorbance of a substance is proportional to its concentration. Filter in the colorimeter is used to select the color of light which the solute absorbs the most in order to maximize the accuracy. Sensors measure the amount of light which has passed through the solution compared to the amount entering, and a display reads the amount absorbed. A spectrophotometer is a photometer, a sophisticated type of colorimeter that can measure the intensity of light as a function of its wavelength. Single beam and double beam are the two major classes of spectrophotometer. The relative light intensity of the beam measured by the single beam spectrophotometer before and after a test sample is inserted, and the double beam spectrometer compares the light intensity between its two light paths. Linear range of absorption and spectral bandwidth measurement are the important features of spectrophotometers. In transmission measurements, the spectrophotometer quantitatively compares the amount of light passes through the reference and test sample, and for reflectance, it compares the amount of light reflects from the test and reference sample solutions. Different types of spectrophotometers. Single beam. In this type, all the light passes through the sample. To measure the intensity of the incident light, the sample must be removed so that all the light can pass through. This type of spectrometer is usually less expensive and less complicated. Double beam. In this type, light source is split into two separate beams before it reaches the sample. From these two lights, one passes through the sample and second one is used for reference. This gives the advantage taking the reference reading along with the sample reading. Visible light 400 to 700 nm, nanometer. Visible spectrophotometer can use incandescent, halogen, LED or a combination of these sources. Plastic and glass cuvettes can be used for visible light spectroscopy. Ultraviolet light. UV spectroscopy is used for fluid and solids. Cuvettes are only made of quartz for placing the sample. Infrared light. IR spectroscopy, which helps to study different structures of molecules and its vibrations. Different chemical structures vibrate in different ways due to vibration of energy associated with each wavelength. Applications. It is used to measure the concentration of the sample. UV spectroscopy is used in detection of impurities and in chemical kinetics study. UV spectroscopy can elucidate the structure of organic compounds. It is used for detection of functional groups. Determination of molecular weight of a compound is possible with spectrophotometry. Basic colorimetry is used to test water quality by screening for chemicals such as chlorine, fluoride, cyanide, iron. Colorimetry is used to determine the concentration of plant nutrients in the soil, etc. Summary. In this episode, we have learned about various analytical and separation techniques such as colorimetry, chromatography, hydrodynamic method, electrophoresis, etc. and which technique to be used is based on chemical and physical properties of a compound or mixture. Also, we saw that these techniques can be either analytical or preparative. Some of these separation techniques have variation which would help in better separation, analysis, and measurement of compounds from a mixture of molecules. Thank you.